Hi, I'm Jyoti.
Hi, I'm Inji.
Hi, I'm Nabil. We are students from the machine learning course taught by Professor Richmond at the University of Virginia.
According to a study in 2015, there are 3.2 million Americans who are visually impaired. Now, this number is set to rise to 8 million by 2050, and there are 168,000 people in the state of Virginia alone who are affected by blindness. We wanted to bring about a change, so as part of the Machine Learning for Virginia project led by Professor Wynn, we decided to create an indoor navigation system that is convenient and cheap. Our goal is to use a smartphone camera attached to the support cane of a blind person, which helps in navigation. It is not practical to train the system in the real world. We use a simulated environment. We are using DeepMind Lab for our environment as it gives a lot of flexibility in its game environment. The starting location can be modeled as spawn points in the game. The target location can be modeled as a goal object. And we also use objects like apples in the map to reward the agent to get to the goal faster. In the DeepMind Lab environment, we use a reinforcement learning algorithm to train the best route from one point in the map to the other.
In order to solve this problem, we decided to use reinforcement learning. Reinforcement learning is a very active area of research that is starting to gain a lot of traction for all sorts of problems from games to robotics. Some famous examples include OpenAI's Dota 2, which managed to beat some of the best teams at the game. There is also AlphaGo Zero, a reinforcement learning agent developed by Google to beat the top players at Go. You can imagine that training a reinforcement learning agent is a bit like training a dog. It takes some action that impacts its environment in a good or bad way. Depending on its impact, the reward can be positive or negative. If your dog behaves, you give it a treat. If it makes a mistake, you give it a timeout, which is the equivalent of a negative reward. The aim of the agent is to maximize the total reward. For this project, we decided to use Q-learning. Let's go through an example. On the top left, the table represents the game map. The mouse is our player, cheese increases the rewards, and the large amount of cheese on the bottom right is the goal. The middle cell of the bottom is poison. If the agent goes there, it will decrease its reward and end the episode. In order to train our agent, we have a Q table, which starts initialized at 0. Each row corresponds to a position on the map, in other words, the state, and each column corresponds to a possible action. The content of the cell is the expected future reward of taking a specific action when it is in a specific state. In this method, we want to encourage the agent to explore the map at the beginning and progressively start relying on the table to choose its action.
So, we have a 7 by 7 map of a maze here. Since for movements the agent takes discrete steps, it appears a lot less smoother. So what we have done here is divided the map into smaller cells so that each step that the agent takes is much smaller and it appears continuous when rendered on the screen. There are basically 3 actions that the agent does. It looks 35 degrees to the right, 35 degrees to the left, and it moves forward. We first train our agent using the Q-learning algorithm. And as you can see, it continuously bumps into walls and doesn't really go towards rewards or goals. This is the initial episode of training, and as the agent continues to explore the environment, the Q table gets updated at every action. As the agent explores the environment more and more, after several episodes, it has recorded a sequence of actions that gives it better rewards, less penalty, and the shortest path to the goal. Imagine in real life, an elderly person with faded vision wants to go to the kitchen for taking their meal. The apples in the maze represent that the person is moving forward. So, with each apple that the agent takes in the maze is like the human is going closer to the kitchen, that is their goal. So, the closer it gets to the kitchen, the higher the reward is, with the kitchen being the highest rewards. Also, the person needs to avoid bumping into the wall, that is the penalty. Reinforcement learning is a hot topic among researchers today. The idea is of self-learning, and that makes it a go-to technology for autonomous systems. Our project here demonstrates just this fact. With the advancement in technology, there might be even more amazing applications of reinforcement learning.